Now there are a couple of other ways that you can do velocity problems still using this equation. So let's take another example. Let's suppose that I traveled a distance. Suppose I was in a plane and I looked at the plane's information and it said that the velocity was 300 miles per hour, and I knew that I had to travel a distance of 900 miles. What can I find out about when I use this equation? Well, let's look at the equation. We know the velocity and we know the distance. Now, a problem like this might ask you how much time it'll take before you get to the destination. So if I'm traveling 300 miles per hour and I have to go 900 miles, in your head you might be able to do the answer already, but let's use this equation just for practice. First thing I'm going to do, find which variables are known. Okay? In this case, the two variables which we know are velocity, are velocity and distance. The second thing you need to do is solve the equation for the unknown variable. Okay, so let's do that. This is the equation we're going to try to solve. What is the unknown variable? The unknown variable is t, or time. We can solve this equation for time by using a little bit of algebra. So let's do that. Better marker. We can say v equals d over t. Now we have to get t on the top, on the numerator. We want to get t over here. And then we want to get everything else on the other side of the equation. So how can we do that? Well, if we multiply both sides of this equation by t, I'll put a t over here and a t over there. Then let's see what happens. This cancels with that. T divided by t is equal to 1. So then we can rewrite this equation as t times v equals d. Time times velocity equals distance. That might be a useful equation by itself, and we'll do another example using that in just a minute. But notice that if I want to solve for time, I'd better get the velocity on the other side of this equation. How can I do that? Well, I have to do the same thing on the left-hand side of the equation that I do on the right-hand side of the equation. So what I'll do is divide both sides of the equation, divide the left-hand side by v. So let me do that. T, v, T, all my numbers are dying. T, v equals d. I'm going to divide the left-hand side by v, and I'll also divide the right-hand side by v. Whatever I do to the left, I have to do the same thing to the right. Now, if you look at the v, there's a v on the top and v on the bottom, so I can cancel those out. And I have a new equation. which says t equals d over v. Now I can solve this problem. So let's go back up to the top, where I still have a little room left on my board. I'm going to plug in some numbers. The time that I was looking for, that's the unknown, is going to be equal to the distance divided by the velocity. Well, let's plug those numbers in. Time equals distance, 900 miles, over the velocity, which is 300 miles per hour. Now, I can do some math. 900 divided by 300, that's pretty simple. That's 3. And what are my units? Well, let's see. I've got miles on the top and miles per hour on the bottom. Over miles per hour. I'm going to put that whole thing in parentheses to show that that is all on the bottom. Okay, what can I do here? Well, I can cancel miles and miles. Miles divided by miles is the same thing as 1. So I can replace this with 3 times 1 divided by 1 over hours. Now that's kind of a strange unit. What can we do with that? Well, it turns out if you do the same thing similar to the equation, if you do the same manipulation at the top and the bottom of a ratio, of a fraction, it'll stay the same. So if I multiply the top by hours and the bottom by hours, then hours here, this is hours divided by hours, and that's equal to 1. And then I'm left with hours on the top. So my final answer will be 3 hours.